Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 2 from section 2-4 in the SavvasRealize Algebra 1 textbook. The goal of this example is to understand the slopes of perpendicular lines. Now parts A and B there, they actually answer, they're at Savvas in a video. So if you have the electronic copy of the textbook, I highly encourage you to watch that video. To be honest with you though, part A, they use some concepts that you don't learn till 10th grade geometry. And so my short and brief answer to part A is sorcery, magic, okay? I'm not going to go into that. I don't want to, ain't nobody got time for that. I'm not teaching you geometry. However, part B allows you a different way than what Savvas does in order to answer part A. Okay, so part B says, how do the slopes of perpendicular lines compare? Well, the answer to that, I'll even type it out because I have messy handwriting, which I'm sure you guys have learned by now, is that the slopes of perpendicular lines are opposite reciprocals. Okay, so let's break apart some of these words here. Okay, perpendicular is what you see here. It's where these two lines cross at a 90-degree angle. Okay, so they meet at a perfect corner's edge. So when we say opposite, we mean that they have opposite signs. Okay, and a reciprocal means that you're taking the fraction that would be the slope and you're flipping that fraction upside down. All right, so they do have an example here with the blue line and the red line. I'm going to give you the generic formula. So if the slope of one of the lines is a over b, the opposite reciprocal would go from being positive to being negative, and the reciprocal would be b over a. Okay, so that's the pattern that you're looking for. So I'm actually going to zoom in real big on this graph, and we're going to count some slopes and see how that looks on an application. So there we go. Now looking at these graphs, I kind of grumble because I always have a hard time finding some anchor points. I see they go through the origin, which is nice. Is it 3 and 4? Yeah, there it is. So there's one. Okay, we're going to do it with both the blue and with the red. So the red also goes through the origin. And I see another anchor point here. Okay, so we're going to compare those two segments. So for the blue line, remember the slope is rise over run. So that's just what I'm doing is I'm counting the boxes. So this one rises by 3 and it runs by 4. So the blue slope is 3/4. And you know that it's positive because if I go from left to right on the blue graph, I'm increasing slowly, right? So it's going uphill. Now the red line, as I go from left to right on the red line, I'm going downhill. So my slope for my red line is definitely going to be something negative, okay? I'm just going to right away put that negative sign so I don't forget. All right, so then I go to count it out, right? So from anchor point to anchor point, looks like I'm falling by 4 and running by 3. So you do rise over run, so 4 over 3. So my two slopes are 3/4 and 4/3, or negative 4/3. So they are opposites because they have opposite signs. And they are reciprocals because 3/4, if you flip it upside down, is 4/3. That's how you know that it's parallel. So if I double back to answer A, you need to take the slope of the first line, find the opposite reciprocal of it, and draw a line there that has that slope, okay? I don't use the weird triangles like they do in their video. Now the triad says, why does it make sense that the slopes of perpendicular lines have opposite signs? Well, if you think about it, right, is there any way to draw two lines that are perpendicular without them having opposite slopes? Like, I would just trial and error it, see how you can do it. The only ones that I could find that are perpendicular, that don't have opposite slopes like that, or opposite signs like that, is a perfectly vertical and a horizontal line. And that's because a vertical line has no slope, right? It's undefined there. So there you have it, guys. That is understanding the slopes of perpendicular lines. Until next time.